Hello, I'm Naveen Khadga and I've chosen chapter 5, problem number 58 from McGraw textbook, that is Engineering Circuit Analysis, which is 10th edition, and I have especially chosen the equivalent resistance problem, like finding the equivalent resistance from complex network. It's mainly about delta-Y conversion, because when you have like too many resistors, you need to use the concept of delta-Y if the circuit is wherever the circuit looks like delta-Y, you have to apply delta-Y conversion. Otherwise, just by using series and resistance can get you the answer, but it can take a lot of time to complete it, and that's why I have used this method so that it can be helpful for future students. And this is my problem statement. Let's not worry about it, we can solve this together. Okay, so this is the question number 58, and it's asking me to find the value of R so that the equivalent resistance of this whole configuration will be 9 ohm. Here is the method, delta-Y conversion. I've chosen this as a delta and Y. You can imagine this as a delta, this as a Y, looking at the figure. And I have calculated the equivalent resistance of this branch, which is 2R by 2 plus R plus 3, which is total impedance in this lower branch, or you can say lower triangle. Same here, I have done the equivalent resistance by multiplying 3 times R by 3 plus 2 plus R, and same goes here. It's nothing difficult here. Now next step 2. Here is the series combinations. 30 ohm and 2R by R plus 5 is because it doesn't have any elements in between them, and the current is flowing, the same current is flowing through them, so they are in series, and this one is also in series. So you got to find R equivalent, which is 30 plus 2R by R plus 5, and here is 10 plus 3R by R plus 5. These are the series combinations, and this whole configuration is in series with 6 by R plus 5. And now let's check if our new modified circuit has series or parallel configuration. If you look at it, we found from the previous slide RA and we found RB, and you can clearly see here these are in parallel because they share the same node. Okay, so this two is in series with R3, and if you find the R equivalent, you will get these quadratic equations. Okay, so just compare this with ax squared plus bx plus c is equals to 0, then you will get the result of R. Here is the step 3. Here is the step 5, where you can see from here R1 is equals to 5.45 ohms and R2 is negative 5 ohms. This is not valid because it's negative, but this is true because it's positive. And if you put 5.45 in the previous slides, here when you plug 5.45, this whole is going to be equal to 9, and that's true. Let's go to the next slide. Here is the second method, verification. I might have chosen to do with just series or parallel, but I stick to use the software tools that I've been learning right now, because why not make the use of MATLAB when you have the software tools to verify? I think we should not hesitate to do it because it's the first thing that's more accurate. With hand calculation it might be wrong, but like software simulation is always gonna be right when you know how to do it. So here I have chosen like a symbolic variation, and this is R, and previously, like I did with the manual calculation, I just assume RAB, RBC, RCA, which is between the resistance between nodes A and B, and you can see all these comments. That's very easy to follow. And I've chosen this display DISP, it means it shows the results. Okay, and after that you use this series combinations, which is 30 plus RAB and 10 plus RBC, and RC is equals to RCA. After that you have to show the output of what RA is, what RB is, what RC is, and you can see here RAB it's already here, and RA is 30 plus RAB. Same thing for RB, 10 is here, 10 plus RBC, which is here. RC is just RCA. And after all this code, you have to find the R equivalent parallel, which is 1 over 1 by RA plus 1 by RB, and RC is in series with the R equivalent parallel. That's why I have added the plus sign here. So this whole equation has to be equals to 9. That's why I equate with the double equals to, which is the symbol in MATLAB, and then I saw the result, what is the equivalent resistance, and you can see the equivalent resistance is 5.45. that matches my answer because I found R as 5.45 when I did with Delta-Wye conversion by hand, and the MATLAB shows the same thing. That means the answer is verified. I hope you learned something from it. Learning something is always good than learning nothing. Thank you. Have a good one.